Yeah, Jack.
Can I just ask, if you want to have 4, like A, B, C, D, you just add squares into the middle?
Well, I'm very glad you asked that question. We just did 3 sets, didn't we? What would happen if we did 4? Okay, now, you want to make sure this is big enough. Okay, so I'm going to do mine over here. Okay, now, common sense would dictate, look, 2 looks like this, 3 looks like this. If you want 4, add another circle. Okay, let's give this a go, shall we? I'm going to draw it like this.
What is this 5?
Let's take it one step at a time, okay? Hold on, I have to concentrate while I draw this. Okay, I think I'll draw it like here.
Overlap all the circles.
Yeah, there we go. Got it. Okay. Now, you have to be careful with it. Let me give you a tip. The way to make sure you draw it reasonably accurately is when you draw these ones and you draw their overlap, okay? The overlap between these two, that intersection, right? Try and make it roughly the same size as this intersection down here. If you make it too, different, you make one big and one small, it'll throw your diagram out. You want it to be nice and symmetrical. Okay, so what do we think of this diagram? Mine's not bad. It's not perfect, but it's pretty good.
Oh, this is crazy.
But it has a problem. It has a problem. Okay. I wonder if anyone can work out what the problem with that diagram is. Let me just label it. I should say, you got the universal set out there. Too many colors. Too many colors. Universal set. I'll call this one A, call this one B, call this one C, call that one D. Okay? Now, just for the sake of it, for instance, one of the problems before, when you were throwing different kinds of Carroll diagrams at me, I'll come to you in a second, minute. One of the problems I said was, where would you put 30? Where would you put it? That was my question, right? Now, clearly, in here, see that? That's the overlap. I'll just wait until you're ready. Let's fix out our diagram, shall we? Right in the middle. Right smack bang in the middle. I do have an overlap, an intersection between A, B, C, and D. But there's a problem. Kaval, I think you had your hand up first, and then we'll go to Brendan. Yeah.
So there's multiple regions that follow the same pattern.
Multiple regions that follow the same pattern. What do you mean?
A and B, and then again somewhere else A and B might appear. Yeah.
Can you give me an example?
Like just that one.
Okay, so this is an A and B?
Yeah.
Yeah.
And then the one on the right side of the
Sorry, here.
No, down.
Here.
And then left opposite.
Here?
Yeah. So as in,
Well, so this would be A and B and C.
yeah.
So I want an A and B and C.
Yeah.
I do want that. Don't I?
Yeah.
Yeah, another suggestion.
You can't have D and B without A and C.
Okay, was that, were you going to say? Okay, so hold on. Brendan, can you explain, since Tom mentioned it, Brendan, what do you mean? Can you point it out to us?
Even though there's sections such as A, B, and C, and A, D, and C, there's no only A and only C together.
Okay, so let me try and replay that in case you didn't catch that. Let's think about ways to get A and C. A and C. How about look at that overlap? It's in here. Here, here, and here. Can you see that? Here, here, and here. But there's a problem. All of these areas, right? In all these areas, you're either in B or you're in D. You can never be in A and C, but not those guys, right? So in here, I need to have 4 sections, but I only got 3. And you can replay it doing it this way, right? Now, just in case you're not convinced by that, you're like, bit hocus pocus, okay? There's an easy way. How many sections were there here? There were 8. I'm going to put the numbers on here again. 1, 2, 3, 4, 5, 6, 7, 8. There were 8 sections. How many sections would you expect should be over here? Now, I heard 16. Now, that's an interesting idea. You're going to need to draw this. 16 is a very good guess. What? But why is it a good guess? This is so important, okay? All right, I'm gonna walk us all through it because I need to go in about 15 minutes, so I'll make sure we get to the end. Okay? Please draw this. You don't need to draw it nearly as big, but draw it underneath wherever you've drawn your 4 circles. Okay? We jumped straight to 3 sets, and now we're taking on 4. Okay? One of the greatest ways you can identify where there's these internal inconsistencies is by taking it back. Take it back, do something simple. For instance, let's do 0 sets. Now you're like, 0 sets? It's a bit boring. Okay, well, just wait and see. Here's 0 sets, there's the universal set, and there's no subsets. No subsets. How many regions are there? There's 1 region, and the region it is, well, there's nothing in it. It's the empty set, is what we call it. Alright? That was 0. 0. Let's add on a set, shall we? So, here we go, small one. Okay? There's a universal set out there, and then you add in A. So now, how many regions are there? 2. There are 2. Firstly, there's no sets, right? And then there's 1 set, A. Okay? So here's one, here's the other one. Okay? Let's go to the case we're more familiar with. 2. Okay? So here we go. 1, 2, universal set, A and B. Okay? How many regions are there? We already know there are 4. But be more specific about the 4. What are the 4? How many ways are there to have no sets? It's just the one. The same one that we've had here. There is a single way to get no sets. How many ways are there to get just 1 set? There are 2 ways to get 1 set. You can either have A or you can have B. Okay? And then, because now I've got 2 sets, I can say, well, how many ways are there to get 2 sets? And the answer is, there's 1 way. 4 ways. 4 ways. Okay? So now when we got to this case here, okay, let's go A, B, C. Okay? Now I counted 1, 2, 3, 4, 5, 6, 7, 8. But what are the 8? Because they're not all the same, and this gets to where my order is. Okay? What was the first set I picked out? It was the universal set. How many ways there are to pick no sets? And there's only 1 way. How many ways to pick no sets? That way. And that's it. How many ways are there to pick 3 sets? Sorry, 1 set. 1 set. Let's get 3 sets later. There's this way and this way and this way. 2, 3, 4. Can you see it? Can you see where I've gone? I've got A, I've got B, and I've got C. Okay. How many ways are there to pick 2 sets? 5, 6, 7. Can you see those regions I've picked out? They're the ones which have 2 sets only. Okay? Namely, you can have A and B, or you can have A and C, or you can have, what am I missing? B and C. Okay. I'm missing 1 more here, right? How many ways are there to pick 3 sets? And of course, there's only 1, right? Namely, A, B, C. So you count them up, and you get 8. These numbers are suspicious to me. Not just that we get 1, and then 2, and then 4, and then 8. So now you have very, very good reason to expect that there will be 16 next. These numbers are very suspicious to me. This is the color I want. Let me try and write out why these numbers are suspicious. What have I got here? 1. What have I got here? I've got 1 and 1. 1, 2, 1. 1, 3, 3, 1.
Oh my god, it's Tussle's trying.
I guess what I'm expecting next is there's going to be, it should be on this diagram, 1 way to pick no sets. The universal set, the empty set, right? There should be 4 ways to pick 1 set. Of course there should be, because I have 4 sets. How many ways will there be to pick 2 sets? 6. There will be 6 ways. How many ways to pick 3 sets, there will be 4 ways. You can write them out. How many ways will there be to pick all 4 sets? There will be just that last region in the middle. And that, my friends, looks like it adds up to 16. Okay, so what do we got here? This is not the Venn diagram that we want. It's not the Venn diagram we want. In fact, there's a proof for this. The reason why this doesn't work is because we have circles. Believe it or not, circles are the problem. Okay? We need to abandon circles. Circles, as it turns out, are too symmetrical. Okay? It's their symmetry that leads to this problem. Okay? So I need a shape that's not quite as symmetrical, but will still do the job. So, here's what I'm going to do. I'm going to show you a few different ways to do this. I'm going to do it like this. Do that one. Do this one. Hold on. I have to really concentrate to get this right. Okay. Now I want one here. And now I want one. Don't screw it up. There we go. Okay, now. It's not as beautiful because it's hard to draw, okay? But we can check very easily if we got it right. Can't we? Let's have a look. How many regions are there? I count 1 over here. I'm going to count 2, 3, 4, 5 over there. Okay. Let's see how we're going. I'm going to go 6, 7, 8, 9, 10, 11. Yes, so far so good. 12, 13, 14, 15. Oh snap! There we go. So, like I said, it's not as beautiful because it's harder to draw. But of course, if you know what you're doing, or you've got the help of something which can draw perfect shapes for you, then this doesn't actually look all that bad. Come back to this guy. Okay? This was our 3-set Venn diagram. Okay? Our troubled 3-set Venn diagram. Actually, there is a way to modify this, and it's not that bad, to get a 4th set onto here. Okay? The only problem with it is, and I don't think it's very beautiful, but it works, is that it's not going to be a circle. In fact, in this arrangement, what you're going to get is, let me try and do this. You're going to get
A smile.
it's kind of a smiley face, clown face, sausage type thing, okay? But you can count it up, you'll get your 16 regions.